In this video, I'm going to go over how to graph a trigonometric function and how to identify some of the key features in that function using the equation and also using the graph. So we're going to begin by graphing f of x equals 2/3 cosine of x. And just as a refresher, on the previous slide, I did go over some key information. So the general form of a sinusoidal function is a sine of bx, or y equals a cosine of bx. So either of these are considered sinusoidal. And that a in front represents the amplitude, and the period is actually given by 2 pi divided by the absolute value of b. So that value that's in front of x. So whether it's positive or negative, it doesn't matter. We're going to take just the amplitude or the absolute value, and we're going to divide 2 pi by that value. And just as an example, if we had 3 sine of 5x, your amplitude in this case, the number in front of sine, would be 3. And your period, we just take 2 pi and divide it by the value in front of x, the 5, and we'll have 2 pi fifths. You can simplify it or convert it to decimal form to 0.4 pi, but that's not necessary. The fractions are perfectly okay. Just make sure to simplify this fraction whenever you can. So let's go back to our example. So we're going to look at 2/3 pi x. So I'm going to just open up the pen right now so I can write. So just as a refresher, we said that general form, right? It's a cosine of bx. And in this case, our a appears to be 2/3, right? We have a 2/3 being multiplied by 2/3 is being multiplied in front of that cosine function. So we're going to say our amplitude is 2/3. And our period, we said it's, that disappeared. I didn't mean for it to disappear, but a period is 2 pi divided by, let me just write that again, cosine of bx. Our period is 2 pi divided by whatever's in front of x. Right now I don't see a number, so that number is 1. It's being multiplied by 1. So it's just going to be 2 pi. So just remember that period is equal to 2 pi over b. So here we just don't happen to have, it's not interesting, we just happen to have a 1. Our midline is actually controlled by whatever we add or subtract to this entire function. So I didn't talk about it on a previous slide because we looked at it earlier, but if I add a value, say I add a value k to this entire function, it's actually going to cause it to shift up. Every value, right, we're just going to add like 1 or whatever, k to each value is going to shift up by k. And if it were negative, if k were negative, it would shift down by k. If we do not add a value, or if k is equal to 0, our midline is going to remain at 0. So by default, the cosine and sine functions, the midline would be y equals 0. So we're going to just leave it 0 for now. Or if it drives you crazy, you can put plus 0, right, to help you envision why we're using 0. The maximum, it's always your midline, right, because you always start in the middle, and it's plus or minus, or it would be plus your amplitude. So in this case, it's 0 plus 2/3, so it will be 2/3. And our minimum will be the opposite, right, your midline minus your amplitude. So 0 minus 2/3, or negative 2/3. We're going to think about x later. I'm going to hold that off for a second, and I'll do all our x values after we do the graph. So now let's take a look at the graph, or let's start to make our graph. And in order to do that, I know a lot of people find it easier to maybe make a table so that you can write down the values. I know not everybody can hold the values in their head. So I'm just going to make a table, fx and f of x. And you've done this before, same way you've done in middle school. Whenever you want to help make a graph, we can quickly graph from a table. As far as counting, remember your extra inputs, you can choose any values you want, but I noticed that my axis isn't counting up by pi quarters, it looks like. So I'm going to try to count by pi quarters just to make it easy for myself to graph. And also what I'm going to do here, I'm going to use this unit circle to help me calculate cosine of x. Remember, when you're using the unit circle, cosine of x is just your x-coordinate. And because it's simple or pretty easy to get multiples of 90 or multiples of pi half radians, I am going to count by pi halves. So I went ahead and filled out my x column, right? I just counted up by pi halves, and I went, no, I stopped at 2 pi. That will be a full trip around the circle or a complete rotation or revolution around the circle. For f of x, I'm going to then just plug this into my equation, substitute it in for x, and I'll figure out my f of x. So I'm going to start off with cosine of 0. So at 0, my x-coordinate is 1. So, and then it's 1 cosine of 0 times 2/3. So 1 times 2/3 would give me 2/3. And now my next one, cosine of pi half. So we travel right here. So, and if you can't remember the radians, right, this is pi halves, this is pi, this is 3 pi halves. Oops. Let me make that a little. This is 3 pi halves. This is 2 pi halves or 0, right? We go back to the start. So at pi halves, my x-coordinate is 0. So 0 times 2/3 is 0. At pi, my x-coordinate is -1. And then -1 times 2/3 is -2/3. At 3 halves, my x-coordinate is 0. And 0 times 2/3 is 0. And then when we go all the way back to 2 pi, my x-coordinate again is 1. And 1 times 2/3 is 2/3. Okay, so I have a nice amount of x-coordinate and f of x, x and f of x pair. So I have a bunch of coordinates. So now I'm going to go ahead and plot them. So one thing I'm going to do for my graph, I just want to make sure it's counting up by thirds. It just makes it easier to plot because I'm dealing with like 2/3. So I'm going to just divide everything by 3. Make sure I have -1/3. Just makes it easier. You can leave it as integers, but then you have to really go in between lines. It's a lot messier. Okay, so now that I have my axis labeled, I'm going to go ahead and plot my coordinates. My first one at 0, I had 2/3. At at pi halves, I had 0. At pi, I had -2/3. At, 3 pi halves, I had 0. And at 2 pi, I was right back to where I started, to 2/3. And notice that the period is 2 pi. So our period is actually the amount of time it takes for me to return right back to where I started, right? We went down and then right back up to where we started. And that is actually the definition of period, and it works out. We can see we're repeating ourselves at 2 pi, or back to where we started. We can also work our way backwards. So instead of going counterclockwise, I can go clockwise, right? So if I go clockwise, I start here, I go backwards, so I go negative pi halves. That will give me the same value as 3 pi halves, right? Same place, so that will give me 0. If I were to go to negative pi, it would give me the same value as pi, so -2/3. So put a point here. If I were to go -3 pi halves, it would be the same value as pi halves, so that's 0. And then -2 pi will be the same place as 0 or 2 pi. I'll be back here. Now, I'm doing this in my head. I'm seeing a pattern. If you can't see the pattern yet, continue the table. So you can still do it one at a time. Do it as carefully as you need in order to get the answers. So the last thing I'm going to do is I'm going to complete this table over here, where we're going to talk about when this maximum occurs. So I noticed that, and I always write the first time it occurs either on or to the right of my y-axis. So we're going to start at x equals 0. The first time I get my maximum is right at the x-axis. So it's the y-axis, so right at x equals 0. So I'm going to put 0 right here. But I noticed that our maximum occurs multiple times. It's not just there, but every time we travel one period, right, plus or minus one period, we also are at our maximum. So I'm going to put plus or minus 2 pi, that's the length of our period, and I'm going to put n, because every multiple of 2 pi, we're going to be right back to where we started. Now for my minimum, see, the first time I reach my minimum is right here at pi, right, as I travel to the right of my y-axis. So the first time is pi. And notice that we have multiple minimums too. And the difference is pi plus pi, 2 pi. So it works the same. So every time we go plus or minus our period, 2 pi times n, we're going to be at a minimum. And the last statement, we're just re-emphasizing what this concept of period means. So for one period, the graph starts at, so we're going to just say it starts here. We start at x equals 0. You can really start it wherever you want. And then it will end. So when does it get right back to where it started? It's going to get back at 2 pi. If you want it to be fancy and start it at pi halves, you can. And then you just need to make sure you add 2 pi to pi halves to get where it ends. But we're going to keep it simple. I like starting at 0 whenever I can. So that's it for graphing. Oh, not it. Actually, I'm just going to connect. I just need to make sure, you see, I'm going to draw a line through my dots. Try to get through. I'm doing it by hand. I want to make sure my maximum and minimum are my points. So this is a rough sketch. Right, and we start to go down. I don't want it to curve. So there's our final sketch of our cosine, 2/3 cosine x. So that's it. Please feel free to try this out on your own. You're going to have a couple more practice problems on your own. And if you have any issues, you can always rewatch this video, but just reach out to me and I can give you more examples.